Hi, welcome back to our Honors Geometry series. In this video, we're going to talk about the Hinge Theorem, which is a theorem that relates the third side of two triangles given that you have two congruent pairs. So if I already have two congruent sides, like in this example, 4 and 5, so 4 is congruent to 4, and 5 is congruent to 5. So I've already got two pairs of congruent sides. Then that third side I know that the third side of one of these triangles will be larger than the third side of the other. And the way that I can tell is that the bigger angle, whichever one has a bigger included angle, is going to open up to a longer third side. So a bigger angle, a bigger angle is going to be opposite a longer side, which is what we just looked at in 5.1, 5.2, and 5.3. And a shorter side is going to be opposite a smaller angle. It also works in reverse. The converse is true. So if I have two pairs of congruent sides, and the third side of one triangle is smaller than the third side of the other, the included angle that is across from the larger side or longer side would be a larger measure than the included angle across from the smaller side or shorter side. So a large angle is across from a long third side. A smaller angle is across from a shorter third side. So let's put this to use. I'd like you to try A, B, and example 4A on your own. Compare your two angles, your two sides, and your two sides. I'd like you to pause the video and try this one on your own first, and then unpause and check your work. So on example 3A, which one's bigger? Well, this one's bigger, which means that it is opposite angle 1, so angle 1 must be larger than angle 2. On B, 123 is larger than 114, which means the opposite side, KL, must be larger than MN. And here, I want to know about AB and BK. But a quick side note, I need to go back to my theorem. If two sides of a triangle are congruent to two sides of another triangle, I don't have that yet. All I have is one pair of congruent sides right there. So I'm going to need to find a second pair of congruent sides in order to use my Hinge theorem. And luckily enough, I've got this reflexive property shared side MB. So now I can use my Hinge theorem. And that means that, well, this must be 110. Means that's got to be 70. So across from 110 is going to be larger than the side across from 70. You could also use our theorem from yesterday that 60 degrees is larger than 40 degrees. But either way, AB should be larger than BK. On B, angle R should be smaller than angle T, so the measure of angle T should be larger than the measure of angle R. And on C, kind of a tough one. What do you think? Which one would be larger? And if you get confused, if you'd like some time to think about it, you can always pause the video. I like to struggle with these on my own, but if I'm not sure, a quick way that you can make this problem easier is by plugging in some number or substituting in some number for x. So if I substitute in a 10, 7 is smaller than 13, but does that always work? I don't know. I'll substitute in another number, maybe 5. And look at that. 8 is bigger than 2, so it worked again. And maybe I'll try it one more time. So if I substitute in a 3, 0 is definitely smaller than 6, so this must be the larger angle, which means that ST must be the larger side. ST would be the larger side. So ST, or the measure of ST, is larger than the measure of RS. So there's our Hinge theorem. And one more question for us, or I guess two more. For my Hinge theorem, I need two pairs of sides rather. There's one pair of sides. My second pair of sides is right there. So which angle is going to be bigger? Would it be FCD, or BFC? And it must be BFC, because BFC is across from the larger side. In our last problem here, find the range of possible values for x if CDF is 2x plus 10 and EDF is 50 degrees. We have two pairs of congruent sides. I want to find the possible range for values of x, but my question is, in the Hinge theorem, if I have two pairs of congruent sides and these are the opposite sides, how could I compare this angle of 50 with its adjacent angle? And again, think about opposite sides. How do these two angles compare? Well, 50 must be larger than 2x plus 10 because 13 is larger than 12. So 40 should be larger than 2x, or x should be less than 20. So there are some possible range of values. If you wanted to get really technical, you could say that x should also be greater than -5 because you can't have a 0-degree angle. So that would be the absolute lowest. We could also use some trigonometry later in the year if we really wanted to find out what D was. But for now, we know that it definitely has to be larger than -5, and it definitely has to be smaller than 20. There's our Hinge theorem video. Check out our other videos on 5.5 and let me know what questions you have.